Okay guys, last time out I set you some questions to have a go at, and hopefully you've managed to finish those, or at least make some good way into them. What I want to do today is give you a little bit of feedback on those. So you've got a mark scheme. I want you to go through your answers and check them and give yourself a score for each. But just with that in mind, there's a few of these areas I just want to have a quick look through. So very quickly, the first one is about electrochemical cells. Which of those would not give a 0 reading? Well, it's the one where you've got two different metals and an electrolyte. So it's copper, zinc and sodium chloride. Water's not an electrolyte, which takes out the sort of the middle one and the end one, and two metals being the same, copper takes out the first one. So it has to be number 3, copper, zinc and sodium chloride. Alkali batteries non-rechargeable. You might remember this from the electrochemical lesson we did. Why do they stop working? Because one of the reactants is used up, or the reaction stops, or something of that along those lines. But one of the reactants is used up will do. Why can alkaline batteries not be recharged? That's because the reaction is not reversible. So again, this is all the work we did on the electrochemical cells stuff a while ago. Right, hydrogen fuel cells. We did this the other day, and you should have hopefully learnt this equation. So what's the balanced equation to make a hydrogen fuel cell? Well, you've got hydrogen, you're making water, so there's got to be some oxygen in there, so there's O2. So there's 1 mark there for getting O2 in there. Then you've got to balance it, or then you can balance it, and if you've got 2 oxygens in an O2 molecule, you must have 2 oxygens at the end, so that's 2 H2Os, which means you must need 2 H's. So 1 mark for O2, 1 mark for the 2 H's. Okay, the next one is a question which is a 6 marker, and this is all about evaluating the use of hydrogen fuel cells compared to rechargeable lithium-ion batteries. It says use the table above and your own knowledge. Now, evaluate is quite a specific word in an exam. It's a command word, and the word, what it actually means is you need to talk about the advantages and disadvantages of each. So compare the data, and at the end of it, draw a conclusion about which is best. So to evaluate, you need to have this is better than that because, this is better than that because, this is better than that because, and at the end of it, overall, this one's better than that one. You need to decide one or the other, hydrogen fuel cells or lithium ion. It also says use your own knowledge. So if you want to get 6 marks for this, you need to not only have decided which is the best, but you needed to have brought something to the table as well as what's on the table in the first place. So I'll show you the mark scheme for this in a second, but let's just talk through what you need to do. First thing you need to do is talk about the time it takes to refuel. So hydrogen fuel cells are better because they take less time to refuel or recharge compared to lithium ion. The distance travelled before refueling for a hydrogen fuel cell is better than a lithium ion one, so that makes it better as well. The distance travelled per unit of energy in kilograms, well, a lithium ion battery is better because you can get 66 kilometers out of a unit as opposed to hydrogen fuel cells. The cost of refueling and recharging, well, a rechargeable lithium ion is much better than a hydrogen fuel cell, and the minimum cost of a car for a lithium ion battery is much better as well. So that's the comparison. So overall, you could say that based on all of those things together, that the hydrogen fuel cell is better because it takes less time to refuel and you get a greater range out of it. Or you could say rechargeable is better because it's significantly cheaper to refuel it, it's significantly cheaper to buy it, and you get obviously less. Or you get a much greater distance per unit. So you've got to decide one or the other. So that's how you get 5 marks. To get 6 marks, you need to bring something else to the table. So you could talk about, for example, the fact that disposing of lithium-ion batteries is particularly bad for the environment. You could talk about the fact that hydrogen fuel cells only produce water vapour as a product, so that's pretty good for the environment in terms of global warming. You could talk about the fact that hydrogen can be produced from the electrolysis of water using, say, solar energy. So it's renewable in that regard. So you need to bring something else to the table to get 6 marks. So this is the mark scheme. Okay, a level 3 one, which is 5 to 6 marks, is a judgment. So you've made a decision, this is better than that. Strongly linked and logically supported by a sufficient range of correct reasons. So you need to get all of those points in for 5 to 6 marks. Okay, if you only get a few in there and some logically linked reasons are given, that might give a simple judgment, that's 3 to 4. If you've not really logically linked anything and you haven't given a conclusion, you can only get 1 or 2. So there's some of the reasons here. And there's some of the other knowledge as well. So hydrogen is renewable if it's made by electrolysis. Lithium batteries might catch fire. Lithium batteries have a finite life. The lithium batteries might release toxic chemicals on disposal. So all sorts of things like that. You might decide to reason why the lithium-ion battery is better overall because of those reasons, or you might decide obviously hydrogen fuel cells for the reasons previously mentioned. So that's a 6 marker. If you get evaluation, make a decision one way or the other. Clearly talk about every single bit of that table. This is better because, this is better because, this is better because, overall this is better. And to get 6 marks, try to squeeze in knowledge that you have from elsewhere. Bring in your own knowledge. Okay? Right, question 2 is a simple cell. This is all about the reactivity. So if metal 2 is more reactive than 1, the voltage is positive. If metal 1 is more reactive than 2, the voltage is negative. The bigger the difference in reactivity, the larger the voltage. This is almost an A-level standard question. It is data handling and it's quite difficult. So just bear that in mind. If you struggle with this, this is where we're unlocking our 7s, our 8s and our 9s in terms of questions. So there's the ionic equation taking place here. Zinc is oxidized. Why is zinc oxidized? Because oil rig, oxidation is loss, reduction is gain. Zinc has lost 2 electrons. Okay, so loss of electrons there. If you're not sure on that, it will all become a lot clearer in Module 7. Right, now it's all about which of the metals is the least reactive. Well, in the terms of those metals there, the least reactive metal is copper. Why? Because it gives the biggest voltage difference with chromium, for example, or because it's the most negative metal. So it gives the biggest size difference when it's put up against other metals. Predict the voltage that might be obtained for a simple cell that has iron as metal 1 and copper as metal 2. So let's just go back up a minute and have a look. Right, so we need the table to help us with this. So here's copper. We're trying to work out what copper and iron would be. So how can we do that? Well, we can look at what the numbers are when we're comparing them against other things. So what you're trying to do is pick a number between those two. And if we look at chromium and iron is 0.5 and chromium and copper is 1.2. So think about how the difference is. Chromium, iron, copper. So the chromium iron gap is 0.5, the chromium copper gap is 1.2. So what's the difference between those? If you take 1.2 away from 0.5, you'll end up with 0.7. So that's the difference. So the answer is it's minus 0.7, and the difference is because copper's less reactive than iron. So it's going to be, if it's electrode 1, minus 0.7. So that's basically it, difference between the two. That's an exceptionally difficult question to answer in an exam. You've really got to have an understanding of that, and it's a data handling question. So if you don't get it, and you're not 100% sure with that, I'm more than happy to ping out some alternatives. But just bear in mind, it is one of the more challenging questions on there. This is the one that unlocks the 7s, the 8s, and the 9s. Okay, guys? So that's your answer there. Hydrogen fuel cells have been developed for cars. Easy starting question. What's the word equation? Hydrogen plus oxygen, arrow, water. The 2 half equations you should have learned. And again, I said there was a variety of different half equations here. The Beeb's got one. The revision guy's got another. I put the PowerPoint with this version on. So this is the one. Hydrogen turns into hydrogen ions plus 2 electrons. Oxygen reacts with hydrogen ions plus 4 electrons to make 2 lots of water. 1 mark for each of those. Apologies for that, it's a train going past. So learn them, guys. Question 3 about hydrogen fuel cells. You'll notice this is almost identical to the question that was in the assessment test, because we nicked an old exam question and they do recycle them. What type of energy is released in a fuel cell? electrical energy. Figure 2 is about why people do it then. So this shows the number of filling stations expected to increase. So 2 reasons why the government might encourage the building of more hydrogen filling stations. So this is all about why do they want us to have hydrogen fuel cells. So using hydrogen prevents us running out of crude oil or saves petrol and diesel usage. You could talk about the fact that hydrogen produces less pollution. It doesn't produce carbon dioxide, it produces only water vapour. So 2 marks there for those 2 points. Basically, why do we use fuel cells rather than internal combustion engines? Then we've got the bond energy question. This is exactly the same as the one that was in the assessment, again, because it comes up over and over. So work out the energy in. The energy in is 2 lots of HH bonds plus 1 O double bond O bond. That gives us 1370. And then you end up forming 2 molecules of water, so that's 4 OH bonds, so 4 times 464 is 1856, and then it's energy out minus energy in, so that gives us minus 486 there. So last question then is about the energy profile diagram, and the energy profile diagram we've done before, so complete it. So first things first, you put the products below the reactants. I've put water in there as the product. It doesn't specifically say that on the mark scheme, but I do it anyway, just in case. You then need that nice little curvy bump thing, which is phenomenally difficult to do in Word. You're welcome. So 1 mark for that. And then the activation energy, I draw a little line across, and it's this arrow is the activation energy, correctly labelled. So there's 3 marks for that. So the purpose of this really was, having finished this little bit of the module, for you to get an idea of the kind of questions that are going to come up in the exam and what they're going to ask. There's probably going to be a long answer question in there about evaluating the pros and cons of hydrogen fuel cells versus others. That will come up in some guise. There's almost certainly going to be a bond energy question in there somewhere, and the hydrogen fuel cell one is a fairly good example of that. It's exothermic, which is why it's minus 486, whatever the number was at the end, and fuels give out heat energy, or give out energy. And there's probably going to be a question about this, either exothermic or endothermic energy profile graph, so make sure you learn those as well. So please go through your answers, check them, anything you've got wrong, green pen your way through, so you've got at the end of it some beautiful model answers. They're going to be very useful when you come back to revise this in the future. So if you could please do that. Again, if you've got really good marks, ace. If you haven't got really good marks, make sure you do. Please be scrupulous on that long answer question. So do have a really good go at marking that. Be honest with what mark you've got, and then modify it if you haven't got 6 marks. Make it a 6 marker, because the more practice you get at doing them, the better you're going to get, right? And without practice, you're not going to be able to do well in these sort of things, so please make sure you do. Okay guys, that's it for the time being. Take care of yourselves, and I'll see you soon.